Okay, so I'm going to talk today about this sequence of studies, as Jeff alluded to, and there's studies that we've been conducting for a number of years. And Caitlin McKay, who's also on the line, Caitlin's now with EDF Canada. Caitlin wrote the paper that brought all of these studies together, and yeah, and I'll take you through them, and then also just pause to talk a little bit about what else is happening on the Canadian methane landscape, because we've been into regulation for a little while now, or about a year and a half into our methane regs, and yeah, we see a lot of motion and some gaps that still exist. So I'll talk about how we're trying to fill those in newer research by myself and by other groups as well. Okay, so as you said, Jeff, I'm out in Nova Scotia. I'm 700 miles northeast of New York City. I had to do the conversion from metric there. And so my research group normally numbers around 20, and we're entirely focused really on greenhouse gas measurement, mostly methane these days. And we do work in both sort of industrial and natural systems. So the natural systems we do is normally near the poles in the Arctic and the Antarctic. And we're biggest though into abatement in some of these industrial studies, especially in oil and gas. And then working on measurement technology as well. So, all right. So I'm going to talk about oil and gas in Canada. And first, I'll just recap on oil and gas production, because when generally, I mean, there's been so much work going on methane research in oil and gas in the US in particular, that when we as Canadians go to the US meetings, we're often a small curiosity. And anyways, I don't know that there's a lot of familiarity with oil and gas production. But anyways, I'll just review it quickly. So in the Northeast, we have shale gas, and those developments are newer. Alberta, sort of in the middle of the frame on the left, is sort of our traditional province, that our oil and gas producing province. Sort of more of the conventional reserves are down south, and the more unconventional reserves up towards the north, where we have oil sands of different types, either oil sands that'll flow or won't flow. Saskatchewan, and southeastern Saskatchewan in particular, is also a historic area of oil and gas production in Western Canada, and we produce oil mainly from Saskatchewan, and so there's sort of regular conventional oil and also shale oil these days. And then on the East Coast, our gas platforms off Nova Scotia have recently closed, but we have oil production off of Newfoundland and Labrador, about 300 kilometers offshore. And there are normally 4 platforms out there, but there are 3 right now. So if we were to, oops, sorry about that. If we were to consider what these areas might look like in terms of their potential to emit, and actually I think I flipped by one slide there. Oh, it's just moving slowly on my screen. Sorry. Anyways, we have different areas venting and leaking. So the areas that are venting are primarily oil production areas, and there the gas is an unwanted byproduct. And then the gas production areas are the ones where we'll see leaks rather than vents. So if we were to look at the potential, basically, and so this is sort of retrospective potential for oil and gas emissions. We'd look at, for example, some of those newer developments, the shale gas developments in the Northwest, and we'd think of them as being probably areas that emit relatively little, because they have new infrastructure, and also they're gas dominated, so there's very little venting. And some of the oil sand sites are gassy in the reservoir, especially this cold flowing heavy oil sand. So we use a process there called CHOPS, cold heavy oil production with sand. And anyways, the potential for emissions varies a lot. Offshore, it's the lowest because gases are managed carefully there and re-injected for safety purposes. So methane emission potential, and the way I basically made this map, sort of in a very qualitative way, depends on a lot of things, as this group knows. So it's the type of production, number of sites, whether the gas smells, and whether local populations will ask for emissions to be taken care of. Safety, as I mentioned, offshore. Regulations also differ from place to place in Canada, as they do in the US. So we don't have national regs. There's mostly areas of provincial jurisdiction. So anyways, all these factors definitely affect the potential to emit. So if we consider how we make our Canadian methane oil and gas inventory, we pick a few hundred sites and we go back to them, or we actually go to different ones every few years, and we measure emissions from all components. We derive averages or emission factors, and we multiply by the equipment numbers, and then we add in some extra things for temporal emissions or for unloadings, and then adjust by production levels, and that gives us basically estimates for the country. And that's the same process basically as is used in other countries, and we know from studies in the US and elsewhere and here as well that generally leaves us an underestimate of emissions. And of the determinants that I mentioned before, I think there are there are a few of them that are covered here in the inventory process. But definitely there are a lot of other ones that are left out. And so with 300 sites, like we have many tens of thousands of sites producing in Canada. And so it's not a very large sample. And especially if there are any local factors that are involved, like reservoir compositions or local regulations, then those don't really get considered. They get largely averaged out. And so we need basically to have larger sample sizes, especially if also we'll take superemitters into account, which are rare and not likely to be sampled if we pick 300 sites at random. Okay, so in 2015 or so, we'd already been doing truck work for fence line reasons, for looking at other gases as well. And we're certainly inspired quite a bit by studies that were happening in the States. And so we wanted to look at our oil and gas sector, and we moved across to working on methane, aiming for some sort of national assessment. Again, as I said, inspired by the US. It is a difficult task for us on the East Coast to take on a big project like this, where most of the production is out west. But anyways, we managed it, and I just wanted to tell you a little bit about how we took it on. So our research aims in trying to do some national work, which ultimately took a number of years, was inventory verification, and then determining what local factors or what regional factors help drive methane emissions, and how we might advantageously reduce them in region by region. And so at the time, I had gone out and tried to convince a number of potential funders that we should do a large national scan, because at that time in 2015 we were already well behind the US. The US is already, many researchers, including me, some on this call, were publishing studies, and so anyways, we wanted to catch up, but there was little interest at the time in large scale studies. And so we basically used a seed model. We took pockets of interest in various different areas of the federal government, NGOs, and industry, and then we had funds for basically tech R&D that we are able to use to extend most of the campaigns. So we could provide matching, because we were while we were doing this work, we were improving some of the truck-based acquisition methods. So for like all told, I think we have about 7,000 replicated measurements in the study that Caitlin recently published. It cost us around $1 million to do that work, which is approximately what I ballparked in 2015 would be required. So that turned out to be about $150 a site for 2 to 3 reps, or something like $50 to $75 a measurement, a site measurement. Okay, so this is basically what our site visits look like. We had a number of areas that were identified from some of the ones I showed you before, between 500 and 1,000 sites per area, or per colored grouping, basically. Groupings show individual campaigns in different years. And then we also have recently, we haven't published this yet, but we've recently been able to do mass balance studies of three of the oil producing facilities that are out in the Atlantic right now. I'll cut right to the end here, and then we'll go back and cover some of the details. So the Environment and Climate Change Canada, so this is the arm of the federal government in Canada that's in charge of building the inventory. If their estimate is at the left, ours is about 1.5 times the national estimate once we take our site level emissions estimates, generate emission factors with those that have some regional nuance, and then apply them to local sites on the basis of some similarity in infrastructure. And there's another study in Canada completed and published in 2020 by Environment and Climate Change Canada itself. They have a number of fixed towers, and using an inversion model with 7 years of measurements, they estimated that the number is actually about 2, that oil and gas was emitting about 2 times what the inventory said, and we landed on about 1.5 times. So in our studies, we would naturally miss some things. I mean, there are obviously different methodologies. The Environment and Climate Change Canada is really more of a true top-down measurement, although potentially with more error involved because there's more modeling and more assumptions. On our side, since we're targeting specific types of equipment and not others, we're not targeting pipelines, for example, or some types of equipment on landscape we're not measuring, or we're not measuring some of the temporal factors as well. So that may explain the differential between us. But anyways, both estimates are higher than the Environment and Climate Change Canada National Inventory Report. So if we start digging into that a little bit and look at the measured values, and so I've basically identified a number of different producing areas in Alberta down the left-hand side here. The black bars are our measured values, and then the orange is reported venting, and then reported flaring in yellow, which is generally small, and then other unreported sources, which are basically the fudge factors that are added into the inventory to make up the gap between the values that are submitted by industry to at the request of the regulators, and what we assume that they actually emit based on these emission factor measurements. So in some areas we see there's a big gap where we measure much more. So Wainwright at the top is the biggest example, where we measure something like 3 times as emissions are 3 times as high as the inventory in that area. And then we have other regions like the high-level Grand Prairie area down towards the middle, where our measurements are actually only about half. But what's interesting is that if we look at high-level Grand Prairie, that gray bar, light gray bar, is very large. So that's the other unreported sources. That's what Environment and Climate Change Canada adds to the reported measurements, which are the orange and the yellow, in order to estimate what the inventory looks like. So so it's possible that we misread for various reasons what we need to add to the measurements in order to make up the inventory. So anyways, there's some area there are quite a few areas that aren't hugely different, but there are a couple of large differences like I've just outlined. Okay, and so it's nice to have these geographic comparisons, because they allow us to maybe get towards better inventory. So if we look at what we saw in the field in terms of emission sources, these are the same that are seen in the US all the time as well. I mean, the equipment is broadly similar. So venting tanks are very important. Sheds that have, their engine sheds, compressor sheds, they have pneumatics and other valves and connectors inside of them are big emitters. Flares, and particularly I'll focus in a couple slides on unlit flares, because we do see some of those here and there, not in high numbers, but where they do occur, they definitely are are in that super emitter category. And then the wells themselves also. So if we look across Canadian provinces, and that's the on the right hand side, the AB, BC, Alberta, British Columbia, Saskatchewan. We have different sort of source types that are active in each area, and that correspond to the type of infrastructure that we see in each area. And so there are a number of studies by our group and others that have basically outlined these different source types. We also have a lot of inactive legacy sites in Canada as well, and most of our publications have provided some estimates, although we've been admittedly a little bit shy about publicizing all of the inactive measurements that we have, because in the last few years, Canada has definitely been moving on active sites, and I think in 2015, industry had a hard time believing that emissions were even there or large. And a few years on now, at least we all realize the patterns, and we realize what types of equipment are emitting, and so we can now start to expand our view a little bit. And some of these inactive sites in Canada, in certain provinces, the inactive sites are allowed to sit on the landscape for a relatively long period of time. They can sit in a suspended form where they're technically capable, but just not producing, for decades at a time. And so obviously there's a erosion of quality of the equipment, and the equipment would be old in general. And so we do often see casing vents or other equipment problems, gas migration issues as well from older wells and poor cementing jobs. We have very high degree of uncertainty on these sources. And so Mary Kang's group, James Williams, who was here first, she and James published a nice paper on this. I guess it was maybe last year, and just highlighted this as a very high area of uncertainty in our inventory right now. And actually, when we look into how the inventory reflects or calculates the inactive site contribution to methane emissions, we find that basically the methodology isn't at all clear. So I think for suspended and capable sites, it uses some emission factors from active sites. For abandoned, they're basically assumed to be zero. For gas migration, there were some gas, like one area of Canadian production near Lloydminster that had gas migration issues in the 1990s as those sites were starting to expand. And basically it was a problem with poor casing or poor cement bond, casing to reservoir. And anyways, the gas migration numbers in the Canadian inventory are applied only to sites in that area, for example, and not to all sites. So we probably have a significant underestimate of the contributions of inactive sites. And so anyways, we do see contributions from some of those. And I think that probably our sort of enumeration of those sort of emissions are really still to come almost. But most of what we published focuses really on the active side. Tank venting is prolific, and as I said, unlit flares fall into the super emitter category for us often. We were in Kindersley, not last summer, but the summer before, in various parts of Saskatchewan actually, and Kindersley is one area, southwestern Saskatchewan, and unlit flares. If we looked at those, because I'd seen a number of them on those campaigns, they emitted on average 3 times more than any other high emitting active type of infrastructure. So although they were rare, they're emitting at very high rates. If you look at the super emitter contributions across all of the different areas in Canada, or the not necessarily the super emitters, but small emitters as well, it seems on an average about 75% of emissions come from about 10% of sites. Certainly some geographies are more prone. So Weyburn-Bakken area, for example, we see here that roughly, I can't see my whole screen here, but anyways, we have a high contribution of superemitters in that region, and it's because most sites are they're sour, and so gases are carefully managed, and then anyways, then something has to go quite wrong for us to see a large emission source in that region. So so we usually have very, very low emissions, and then we have occasional very high emissions when something's wrong. So anyways, all areas have somewhat different propensity to emit heavily. Offshore, as I said, we've been doing flights offshore in recent months through the fall, and we see that there's a quite different story in the offshore. So the values that are reported by the operators to the federal inventory actually seem to be quite close to what we measure. So so for onshore, we measure about 1.5 times more, and for the offshore, it's very similar. And you know, we don't have you know, indications you know, very clearly on what's happening in all cases on the platforms, but certainly some conversations that we've had with operators and lead us to believe that they have you know, quite a good understanding of what's happening at any given time at the facility. So as I said, the gases have to be managed more carefully in the offshore, and so leads to a better understanding and a closer correspondence to inventory. I should say that that one of the differences with offshore production in Canada is that we have very low methane intensity, basically, compared to the onshore, as a result of some of these factors. So although the facilities are individually emitting fairly high amounts of methane because they're producing very large quantities of oil, so I think the offshore production from the 3 platforms is about 10% of all of Alberta's production. Anyways, on an intensity basis, it's very, very low. So what's next in Canada? So I'd say that we have shifting responsibilities now. So so this work started in 2015 and is finally rolled out now. It did take a lot of time, and we now have regulation, and we see from some of the early regulatory submissions that the regulators need you know, sharper teeth for sure in some cases, that we'd like to see compliance levels a little bit higher, and also better rules. And so I think our research is shifting somewhat from field measurements to work that tries to highlight some of the gaps in regulatory reporting, effectiveness, and also transparency. So the figures I've listed here are from a study of the top 70 producers in Canada, where we're looking at different inventory realizations of their emissions and comparing all those inventory realizations to values that are published in the ESG reports. And Petronex on the left hand, so all the producers' names there are scrambled, and on the left hand side, Petronex is the industry reporting system for venting, at least venting fuel flare vent, and anyways, we don't have access through to the fugitives reporting yet, and anyways, hopefully that will come in time. It's come for one province so far, but for this study we just used Petronex, and so you look at the x-axis values between these are quite different. As I alluded to in earlier figures, Petronex submissions, this is the venting, makes up often a relatively small proportion of what the actual inventory value is. The assumed inventory value, if we deaggregate the inventory by producer, which is the middle panel, ECCC, Environment and Climate Change Canada, it's the federal government, we see that all of a sudden the numbers jump up quite a bit, almost an order of magnitude in some cases. So producers are only submitting sort of 15 or 20% of the total numbers. What we see that's really interesting is that there's a very wide range between of methane intensity. So these are gas dominant producers. So the methane intensities here are basically leak rates. That we have very high difference, like around 100 times between, or more, in fact, between the methane intensity of some producers versus others. And this is largely on the basis of the infrastructure that they own. And if we deaggregate our measurements in the same way as the Environment and Climate Change Canada one, panel in the middle, we actually see that we rank producers in a very similar manner to Environment and Climate Change Canada. That is, from measurements show us who should be the heaviest emitting versus the lowest emitting, but the differences are maybe even drawn out a little bit further. So where we have leak rates that are up to around 7% in some cases, generally under 2.5%. And for most of the larger production, it tends to be the larger producers are closer to the bottom of this list in many instances. We have, I'm not sure if you can see on my cursor, but these are leak rates that are less than 1%, which is where we want them to be. So some of these intensity metrics are pretty interesting. If we compare these to ESG reports, some producers are reporting their true emissions, and their emissions will closely match ours, but that's a relatively small number. Many other producers are reporting in their ESG reports what they report to the industry submission system, which as we know is an underestimate based on the way that the inventory is built. So anyways, more work of this nature, I think, is going to be important because we have regulation and we have ambition to improve it and make it more stringent. We have new measurement. Instead of 45%, we're now interested in 75% cuts in the oil and gas sector. So we're not going to get there unless we have better data. So what else is next in Canada? So we need to decrease uncertainty in some key areas. So we're working, for example, on more well integrity measurements. There are a number of sources that will become an increasingly large slice of the pie that aren't currently included in our regulation. And if we want to achieve 75%, we're going to have to dig into some of those. So that's gas migration and surface casing vent flow issues, inactive sites as well, and reconciliation between different types of measurements and scales, where we're establishing a few observatories out west. So these are like site areas basically that we'll return to annually. And then we're still interested in tech as well. So we're interested in, like we're currently working with wherever the arrows are pointing, we're currently working with stationary monitors, new stationary monitors, on new mobile techniques, and satellites, as well as gas migration, also some aerial as well. So anyways, we have like quite a number of areas in which we're either supporting existing outfits who are developing tech, or we're developing tech of our own. And so other great work going on in Canada is the study that's happening right now that's joint between Carleton and EDF and funded by a variety of different entities, including big contributions, I think, from BC government as well, who have a lot of interest in this work. Anyways, it's a quick scan where we took years to try to make some of these measurements. We can now make them faster by aircraft, and so Matt Johnson's targeting a similar number of sites. And so we're into just over a year into regulation now, and so if our measurements sort of were the baseline, anyways, this is a more modern estimate and done in a more modern way, which is really great to see. And well, we're going to have to do this often, and there are a number of us that have been calling for a national anthropogenic methane observatory. So that wouldn't be on the backs of researchers, obviously. So we wouldn't be able to do that, and we also don't specialize in doing things more than or we don't like doing things twice, basically, in research. So it's important to spin off the repeating work like this, or the know-how to do it. And so we really like to see this as a centralized, agency or something like that in the federal government that aligns, Agriculture Canada with Natural Resources Canada and Environment Canada, various ministries who have who play in the methane space. So there are some ongoing discussions here. There are also some good large scale, integrated networks to look at for examples and how they work, like the US NEON that I've been involved with over my career. And in Canada, if we're making investments in this area and if we're requiring industry to make investments, we had better we better understand the numbers well to be able to defend our choices and to track progress. And we also want to be competitive as well. So our oil and gas sector won't be competitive if we don't have good numbers. Even if we were the best performers, if we couldn't prove it, then we're not the best. So we in our research group in the Flux Lab, we're also looking much more at agriculture and waste as well. So in particular for waste, we're quite interested in gearing up national scale projects, because we've already done some agricultural work and we have difficult issues there, like lack of activity data. At least we can gain access to all the infrastructural data in oil and gas that we need. But in agriculture, it's really difficult to figure out how many head of cattle are on a particular farm, where the farms even are. A lot of them aren't registered properly, or it was really difficult to figure out who's doing what type of manure management. So we've done provincial level activity already on agriculture, but it's very difficult to correlate emissions data with what's going on at the ground level. But for landfills, it's a bit clearer. Sites are fairly well known in location. Landfills tend to be professional. They're located near towns. They don't like smells. They have been accustomed for a long time to complying with different types of regulations, and they're basically industrial facilities as well, which also helps. So there's a degree of professionalism there, and also mitigation potential. So that would be our next big source in Canada behind oil and gas, and so we're trying to do measurements in that space too. So that's all I have. I think Evan and Jeff asked me to keep it to around half an hour or so, and to allow time for questions. So happy to field questions on any of this work from those in the audience. And again, thanks Evan and Jeff for inviting me in today.